This
Madison.
conference will now be
We're
recorded.
just this is your project, and it is just it's a great combination of animation and coding and creativity. And I believe uh, there's a little bit of just ingenuity in that. And again, great opportunity there, and great work for bringing that to your this opportunity to your class. So trying to do two things here at once, but let me get over to introducing our esteemed guests. Our first guest here is Christy Cox. She is the Utilization and Commercial Use Manager in the ISS Division in the Human Exploration and Operations Mission Directorate at NASA headquarters.
Very good.
She has a BS in Aerospace Engineering from the University of California in San Diego, and loves to knit, sing, and travel. Our second guest is Dr. Kathleen Gallagher Boggs, and she's Assistant and Technology Demonstration Manager for the ISS Division of the Human Exploration and Operations Mission Directorate, with a BS in Materials Science and Engineering from Carnegie Mellon University, and a PhD in Physics from Trinity College in Dublin, and is also a drug-free bodybuilder, which is amazing. But I'm going to go ahead. They want to talk to you about the amazing things that they are doing, and I'm going to pass this off to them. So just give us a moment while we hand things off, and then they can take it away. So here we go.
Hi, how are you guys?
Good.
Good. So I have a question for you. How many of you guys know that we have an International Space Station? Everyone should raise your hand.
Yay.
Okay. Main presenter. Give me a second. I'm trying to figure out what the information technology is doing to me right now. Share this screen. Okay. All right. So Christy and I, you've heard in the introductions that we both work for the International Space Station program. And we work on a couple of different things. In my role, I worry about what technology we need to do. We need to build and fly on the International Space Station to enable deep space exploration. Christy's role is cool because she worries about how we get private companies to come use the space station. So let's see, actually, I'm going to take this off. I have this on presentation mode, and I've just realized that I can't see you guys when I do that. So let's end the show. Okay, you guys can see it this way, and I can see you. There we go.
There we go.
That's much better. Okay, so what do you guys see in this picture?
Astronaut.
Shout it out.
Astronaut.
Astronaut.
Yeah.
What's the astronaut doing?
Spacewalk.
That's a spacewalk.
Very good.
So first bit of NASA terminology for you today. Christy, what do we call a spacewalk here?
We call them extravehicular activities, or EVAs.
So if you want to sound cool, you can next week. We have a spacewalk coming up, not next week, in a couple weeks.
There's a Russian one.
Russian one. Oh,
Yeah.
Well, we don't like the Russian ones. No, they're cool. But you guys can say that you watched an EVA on NASA TV. So this is a kind of a cool picture because you can see the astronaut when they're in space. They have the helmet, they have their whole life support system on their back, and they actually do go outside the space station. In the lower corner, you see something that looks like our solar arrays. So let's talk about the space station. Oh, it's not going to do that for me. It's trying to nudge something. Here we go. Okay, so the space station is about the size of a football field. So from end to end, it is 240 feet long. And each of those black panels you see in this picture, those are what we call solar arrays. So the space station uses solar power, just like some people's houses use. It uses solar power to provide the energy we need to manage the life support systems and do our science experiments. Each of those solar arrays is how big, Christy?
They are exactly 350 feet wide and 45 feet high. You were asking me a different question, though, that I did not answer.
So who knows how long 350 feet is? What does it compare to?
The football field.
No, the solar arrays. Well, oh,
I'm obviously missing something here.
she doesn't
You
follow
guys know?
basketball. So solar arrays are the same size as a basketball court.
No.
Okay, so any of you guys play basketball? No, yeah, there we go in the back. Okay, so for you basketball players, those when you're running from basket to basket, that's how big the solar panels are for the space station. So they're pretty big.
So next time you run suicides, you can think of that.
Okay, so if you can imagine though, we took those solar panels and we like folded them all down really small and put them in a box and then launched them in the space shuttle up to the space station to assemble it. Oh my gosh, it's quick clicking on everything. So
Want to talk about assembly?
why don't we talk about something? You should talk about something.
I'll talk about assembly. So assembly, it took 41 flights beginning November of 1998. What year were you guys born?
2005.
So you guys have not known a world where we haven't had someone living in space. That's really remarkable. Since 2000, we've had people living in space.
So
continuously.
So 24 hours a day, 365 days a year. There's been humans, as many as 6 humans at a time, living in space above you. So,
All the time.
All the time.
So, you know, building the space station was no small feat, as you can imagine. We call it international for a reason. We have different nodes that were, we call module nodes. Think of them like lighthouses. They were built around the world in Russia, in Japan, in Europe, in America. And then they go up on a space shuttle or another craft and they go together for the very first time in space. They were not check fit on the ground. Think about like putting your USB in your computer. It always takes me like 3 times before I can actually get it in there.
Yeah,
we have
or your phone cord, like, you know what a pain in the butt it is to try and plug in your phone while you're doing something else.
Yeah, they didn't have that chance. They had one chance to actually get it together, and they first time for every single one. So,
and each of the modules, a lot of them were built by different countries. So if you can imagine, someone in Japan built a big portion of the space station, and they never had the opportunity to test them together. And so the Japanese one flew up there and attached to the American, and we had no issues. So we really have to work hard to collaborate with people in different countries in order to do things like that.
Yeah, and communication is key for all of this.
So let's see, other fun facts. There is 8 miles of wire in the electrical power system. So, you can run like, what is that, like a 10K? Yeah. So the space station wire could cover 8 miles. It's probably further than you guys have to go to get from your home to school. So it's a lot of wire. There's a lot of computing that goes on, and there's how many computers? There's a lot of computers on the space station too.
There are quite a few.
Yeah.
I almost want to say like a third of the racks are dedicated to our systems and our computers up there. And then also like the actual livable space, it's about the size of a 5-bedroom house. More like, in Texas, not in DC.
Yeah, like
small.
Yeah. I forgot, where are you guys at?
Lewiston, Idaho.
Okay, so you guys have some big houses there too. So it's about like the houses you guys might live in.
Yeah. The homes here in DC are very small.
Yeah, we live in the city. There's not a lot of room here.
No.
And let's see, we've had hundreds of astronauts now, and over 100,000 different people have been involved in 16 different countries in building and maintaining and operating the space station. And I think finally, how far up is the space station?
Oh my gosh. It's been a long day.
I know. It's about 220 miles above the
I was
Earth.
going to say 256.
Yeah. I think it depends on the day how far it's fallen.
Yeah. How fast does it go, Katie?
You
had to look too.
17,500 miles per hour. It's on my slide.
Yeah.
So, question for you guys: how long do you think? So we put an astronaut in a spaceship. Well, we like to call it a Soyuz vehicle because the Russian vehicle takes the astronauts up there. How long do you think it takes the astronauts to get to the space station once we launch them? Anyone have a guess?
2 minutes.
2 minutes.
Whoa!
I would love that. Can you get to school in 2 minutes? 1 day? That's a pretty good guess.
Yeah.
We've got it down to a few hours, but yeah, usually about a day from when they leave Kazakhstan to when they arrive at the space station.
Yep.
And how long do you think it takes for them to return?
A week.
A week? So, so it is less time.
Yep.
It's a few hours. And part of the reason for that is when the space station launches, or when the space vehicle is launched, they have to get out of Earth's atmosphere, and then they actually have to orbit the Earth for some time until they catch up with the space station. The space station is traveling, and this guy's kind of like looping around until they meet up.
Trying to catch it.
So that's why it takes time to get up there. But when they come home, they pretty much like push away from the space station, fire a few rockets, and they enter because gravity is going to bring them down.
Yep.
Right. So when you're leaving, you're trying to escape gravity. When you're returning, you've got gravity on your side. So NASA in the future wants to do more than just go to the space station, right? So you guys probably know it's about the 50th anniversary of the first moon landing. You guys know who first walked on the moon?
Neil Armstrong.
Very good. Who was number two? Who was number two?
Michael Collins.
Buzz Aldrin.
Yep.
You guys know Buzz? So Buzz is still with us, thankfully, and he is very, very motivated by getting humans to Mars. He had the joy of getting humans on the moon, and he thinks that humans should go to Mars. And so this little chart is it talks about the difference between the space station and the moon and Mars. And so to return from the space station, it's about 3 hours. And well, here we've written about 250 miles, and you're going 17,000 miles per hour. To return from the moon, you actually are going to take 3 days. So it's that much harder. So you can imagine if an astronaut hurts themselves on the moon, or if they get sick, and there's not a doctor right there, like you can't just go to the emergency room on the moon yet. It's a lot harder. And if we want to go to Mars, getting to Mars and returning from Mars takes 9 months. So if you want to do a trip to Mars, you have to spend 9 months flying there. You actually have to orbit Mars for some time so you can do something. Because if you go to Mars, why are you just going to Mars and coming back?
Right.
And then it takes you another 9 months. So really, in total, we think that a Mars trip would be about 1,000 days. So it's 1,000 days away from your home, 1,000 days without, like regular resupply from Amazon. And so it's a long time to go. And so, my gosh, all my notifications.
Some of the, we talk about what makes a good astronaut. You need to be fun to be with in a small space for a long period of time.
Yeah. So like, how you, like, your little brother annoys you? Like, you don't want to have those like little brother fights when you're stuck in a little can in space for 3 years, right? So selecting an astronaut and living in a small space, because we think, the space station's like the size of a 5-bedroom house. A vehicle going to Mars is going to be like the size of a 1-bedroom apartment. So it's a lot smaller space, and you have to be able to get along with the people in there.
Yep.
So the last thing we were gonna tell you about, and then we're gonna give you guys lots of time for questions. So who heard that the president has new plans for NASA? All right, so I think, is that Madison there in the front? So what is the plan that the president and the vice president announced?
They want to go farther to the Mars, and they want to expand space travel further.
Very good. And did you hear what the name of the new mission is that we're working on?
Forward to the moon.
Yes, when you study for the Tinker, that's what we were saying. And we envisioned a series of missions. And of course, it's not going to do this for me. So we're calling the next set of missions that are going to the moon Artemis. So does anyone know what Artemis is, or who Artemis was, let's say? Nope. Did you guys study mythology yet? You're in 8th grade, so. Yeah. Oh,
The hunting god.
I can't. Can someone repeat the answer?
A hunting goddess or god.
Correct. Yes. And in fact, Artemis was the sister of Apollo. And so Apollo was actually what we named the moon missions in the original moon missions. So we've chosen this name Artemis that to reflect that this is the sister of those missions. But the difference here, and when you look at this picture, and we won't go a lot into this right now, but you guys can look at the pretty graphics and understand it. We're going to do a series of moon landings. So we're not just sending 2 guys to go bounce around on the moon and like take pictures of the flag. We're actually looking to start building up more of a moon base. And so we're really excited about this. It's going to be a tough challenge. And, you know, since Christy and I both work with the International Space Station, we're excited because there's a lot of lessons we've learned from Space Station about how humans can live in space. And we think that we can use what we've learned there to help the humans live on the moon. So
things like life support.
Life
We've
support.
learned a lot about how to run life support.
So just like your house has, you know, heating and air conditioning, plumbing, that's what we call life support systems with the space station program. And you can imagine in space, because you don't have gravity, all those work a lot differently.
And the mechanics can't just hop in a car and drive up to your house when something breaks.
Yeah, so astronauts spend a lot of time fixing the toilet themselves. So they're the smartest people in the world, and they're
really good at fixing.
They're really good at fixing toilets too. Yeah. So
and not only that, you have to bring your own air, you have to bring your own water.
Yep.
It's just things that we normally take for granted here on Earth, we have to bring up with us.
And we also look at recycling as much of it as we can. So we're trying to make it so that we recycle 98% of the water on the space station. So that means, you know, anything that the astronauts pee out, poop out, you know, the sweat, we capture that and we purify it and we use it. We take water out of the trash. So a lot of trash has water in it. So any waste products we're looking to reuse. And those have benefits on Earth because recycling technologies we develop in space, a lot of them work on Earth. And there's parts of this world that have issues with water. And so we are able to transfer those things to benefit people on Earth. So,
yeah.
Anyway, so I'll tell you guys, this girl right here is an expert in life support systems. So if you want to hear more about that topic, I'm going to let Christy answer those questions. But we'd like to give you guys time to ask us any kind of questions you might have about space travel, about the space station, about moon plans, Mars plans. I do a little more Mars work, which we didn't talk about yet. But what do you guys want to know?
So what is the communication going to be like on like the moon base in Mars? So like how will we communicate with Earth?
It's a good question.
It's a good question. So the moon is so far away that we have a few seconds delay. So have you guys seen the movie The Martian?
Yes.
Yeah.
Okay, so remember The Martian, like he had to like send a message and then wait 20 minutes for them to send a message back. So we have the same problem at the moon. It's just not as big. It's 20 seconds, not 20 minutes. So, but it still gives us an opportunity to practice operating in a way where you don't have instant communication. So at the moon, it's gonna be a lot more like, you know, like when you text your mom, like, Mom, I wanna like buy this app, and you have to wait for like a minute for your mom to tell you no. It's gonna be more like that. It's more like text messaging in terms of the delays. And we're working on some technologies, working on using lasers instead of like radio-based communications. So that will help with it. The lasers will be faster and you can do a lot more data. And that's one of the cool things now because, you know, when we did Apollo, we didn't have a large volume of data. So it's part of the reason why the videos you see are very grainy. The video technology wasn't as good and we couldn't send as much data back. But now we can send a lot more data. And so you're gonna get much better pictures of what's going on the moon.
Yeah. Good question.
Yeah.
What else?
Oh.
How much money would it take to get to Mars?
I'm gonna have to repeat that.
Shout it
How
out.
much would it take to get to Mars?
How much something to get to Mars?
Money.
Money.
Money. Oh. Well, so we've been estimating that. So for the moon mission, we're looking at several $billions, and we would expect the Mars mission to be the same. It really depends on the design. Like, we think that we could do, there's some calculations that say you could do a 2033 Mars mission using existing technologies and a really minimal, like just go there and visit and come back. You don't do a whole lot. And that would cost about the same as the space station costs, which is $3 to $4 billion per year. So it's a lot of money. But if we want to do more than that with Mars, then it's going to be more money.
We want to go to Mars, not just to go there, but we have a lot of research that we want to do on Mars.
So we really want to go to stay. Yeah.
Yeah.
And what we're hoping, though, is with the moon mission that we can learn things that will help us save money with the Mars mission. Right. So we call that reducing risk. You know, you hear about adults talking about risk stuff. And so that's part of the reason we go to moon is to learn about those things so we can approach Mars in a less risky way. And usually if we can reduce that risk, that'll save us a little money too.
So if we want to colonize Mars, for like food resources, would we have to like bring this like growing plants up there, or would we also bring livestock with us too?
So a little bit of both. So we do something, we're looking at something called in situ resource utilization. So Mars and Moon both have some water resources we think we might be able to use. It's all ice. And we don't really know, is it more like dirt with some water in it, or is it more like water with some dirt in it? So we need to do more study in both places. And the Mars ice, we think, is well below the surface. It's really far down. We're going to have to dig it out. Also, Mars does have a little bit of an atmosphere, so we may be able to use some of the gases in the atmosphere. And so we are looking at, in particular on the moon, we're looking at ways that we can reuse those resources that are there. There's some talk about using like moon rocks or even Mars rocks to be the building blocks for your habitat, which is what we mean for the building. We say habitat like you're a gerbil or something. And but we're also going to take things. So like I was thinking like veggie, like we're talking about growing plants. Maybe
so we're working on the space station the most efficient way to grow plants, because it's actually hard to get water to them because it's in microgravity. So, you know, we're expecting to take plants. Where'd they go? There they go. Sorry, you disappeared for a second. We're looking at taking plants with us to not only, you know, just it actually helps with crew morale a little bit, just having plants in there.
They like taking care of them.
Yeah, with that, and just imagine not being able to go outside for a long period of time. It actually affects you a little bit, but and not only that, but for food
and fresh food, like people, like if you ever ate, like I know eating McDonald's every day or Burger King probably sounds great to some people. Pizza every day sounds great to some people, but the astronauts get tired of eating the same food every day. So having plants allows them to have a fresh food supply, so that's not all prepackaged for them.
Right.
So it's we're looking at taking some of that, and then other things we would have to take supplies with us, and there's some things that we would print. You guys, have you seen 3D printers?
Yeah.
Okay, so we have some 3D printers on the space station, and we're learning how to print parts in space. And some things we're working on include taking, like, everything goes to space stations in a Ziploc baggie. It's not really Ziploc, it's something else. I don't know. So it's a plastic baggie, and we're looking at ways that we can take all those plastic baggies when we're done with them and melt them and use them to 3D print stuff that we need. So like if something breaks on the way to Mars, we would be able to print the part in the spacecraft and then use that to replace it. Rather than taking a whole bunch of spare parts, we'll just take files that tell us how to print the parts.
Yeah.
Before we go, and I just want to make sure, just going to jump in here, that Madison gets a chance to at least ask a question too, since she's the reason we're here. So Madison, if you have some questions.
Mostly about what kind of school should you go to, or what subject should you study to get into NASA or a job in that field?
So Christy has a great story.
I do actually, I think. So I personally wanted to work for NASA since I was like in the 5th grade. So went to space camp 5 times, like you do, and got a degree in aerospace engineering. And NASA has a program, I think it's called Pathways, now at Johnson Space Center, but it's I was hired as an intern there, and then right out of college, I got a job. So it's actually really relieving when you're in your senior year and everyone else is applying for jobs, and you're like, I got one. That's with NASA.
Yeah.
And so because of that, I've been able to bounce around and do a lot of different things. I have my degree in aerospace engineering. If you want to be technical, I highly recommend mechanical engineering, electrical engineering, something kind of more basic. Aerospace, you can take electives. But I have not done a lot of engineering since I started with NASA. I've worked with the food lab, so the different food the astronauts get to take, managing life support system projects, managing emergency equipment projects, and then right now I've been working a lot with this commercialization policy. So it really kind of depends on what you want to do. There's a lot of people like nutritionists that we have that work at NASA. We have lawyers that work at NASA. So the best advice someone gave to me, I interviewed a lot of people because I wanted to work for NASA so badly, and said, what do I need to do to get there? And they told me, find something that you love to do.
Yeah.
And try and apply for jobs that way. But at the end of the day, if it doesn't work, you're still doing something you love.
Yeah, and I think one of the things that Christy brought out here that's important is that the space industry is growing right now. You guys have all heard of SpaceX, I'm sure. We have other companies like Blue Origin. There's just all kinds of small space companies out there. And so if you love space, but like you're not a scientist or an engineer, all these companies have needs for lawyers, for public affairs people, HR people, finance people. Oh my gosh, the money. I mean, you just heard me talk about billions of dollars. So you can imagine that accounting is really important in the space business. So if you love space and you don't want to be an engineer or a scientist, there is plenty of room for all the other fields in space. We work with graphic designers. I have friends with degrees in public policy, economics, that work here at NASA. And if you are into engineering and science, then, every field of engineering and science is represented at NASA. And my advice is to pick the field that you enjoy. So most of you, you guys are entering high school soon. So, you need to take, if you want to pursue science and engineering, you need to take the math classes and the science classes. There's no way around it. Also pay attention to English, because we both, even though we're in quasi-technical roles, we have to write all the time. So understanding your grammar rules is really important, because you can be the smartest engineer in the world, but if you can't write it clearly for someone to understand, then your ideas won't get any attention. Yeah. So you have to, like, English. I hated English, but I write all the time. So you have to be able to do that.
But you're writing about a topic that you love, so it's. But I think the big thing that I wish I had done when I was your age is I wish I had learned more about myself. I was so focused on working for NASA,
getting A's and
everything, that I really didn't pay attention to what I was good at, what I liked doing, and it worked out beautifully for me. But I was very lucky.
Space.
It was like space. I'm just gonna do space. But start paying attention to that now, of what you're like, what you're good at, what your strengths are, what your weaknesses are. Do you even like science and math? I loved math. So it was. I still had my kind of STEM route, but learn about yourself. If space is something you want to do, you can make sure that you're setting yourself up for success early, rather than realizing it later on that you're just unhappy with what you're doing.
Yeah. So does that help, Madison?
Yeah.
Okay.
Good.
Hey guys, it's me.
You telling us time to be done? No.
It actually looks like we are at our cutoff mark, but I did want to thank you once again, Dr. Boggs and Christy Cox, for joining us for today. Madison, again, great job.
Great job.
I know you have some.
We judged those patches, so we saw them all. So yours was really good.
Yeah.
But one thing I love about it is that the work that you do has opened up and given your entire class and your school an opportunity, and I think that's just a great thing. So keep it up. A big thanks to Lewiston and your administrators there for working hard to make sure that you guys were able to pipe everything into that room. Do you guys have any final thoughts or notes?
From us?
Sure.
Sure. Well, I just want to say also thank you to your teacher, because I think it's always great when you have good teachers who are helping you guys learn these things, and you were really impressed with the coding that happened here. So
Yes.
you know, I'm assuming that was all Madison, but had good influence from a teacher. So thanks to your teacher too.
All right, my
And-
friends. I think we're done. All right.
Thank you guys. Fantastic. Thank you.
Congratulations, Madison.
Once again, thank you very much for giving us this opportunity.
Thanks again, everybody.
Bye.
Take care.
Okay, he's gonna end this thing, I think.
Last wave of the camera.